Hello students, this is a Regents Review video about completing the square. This was a student requested video. In order to complete the square, you need a quadratic equation. Completing the square is a method of solving a quadratic equation, so maybe I'll write that down. Completing the square is a method to solve quadratic equations. It also allows us to rewrite quadratic equations in what's called vertex form. And you'll see what I mean in a minute. So I'm looking at this quadratic. It's not solved for 0 yet, so the first thing I'm going to do is solve it for 0, and then I'm going to show you the method for completing the square. So now I have rewritten the quadratic equation. I'm going to solve for 0. In other words, I'm going to subtract 25 from both sides. I'll show that here. And the next step I get is x squared minus 6x and then minus 16. Now, my next step in completing the square, I need to get the c term to the other side of the equation. So I'm going to add 16 to both sides. It might seem like I'm flopping numbers around a little bit, but the reason I'm doing that is because I need to get the x squared minus 6x part by itself. So I'm adding 16 to both sides, and I get x squared minus 6x, this piece, on the left-hand side, and that's equal to 16. So now what I need is to take this middle number, this b term, which is negative 6. I need to divide it by 2 and square it. That's going to give me my new c term. I took out this old c term, which was negative 16. I need to find my new c term. So what I'm going to do is I'm going to take the middle term, the b term, which is negative 6. I have to divide that by 2. And then I have to take that entire quantity and square it. So I'll represent that in this way. And you know that negative 6 divided by 2 is going to give you negative 3. And then when we square that, that's going to give us positive 9. So negative 6 divided by 2 is negative 3. And we're supposed to square that to get 9. Let's throw this squared on there. And remembering that the c term is going to be taking the b term, dividing it by 2, and then squaring the whole quantity is something that you need to remember. That's one of the formulas that isn't on your formula sheet. It's just something that you have to keep in your memory banks. So now that we know that the new c term is supposed to be 9, what I'm going to do is I'm going to add 9 to both sides because I need the new c term here. And I'm going to add 9 here. And I get x squared minus 6x plus 9. So this piece, which is x squared minus 6x plus 9, is equal to 25. Okay, completing the square, right? We need to turn this part into a square, in other words, a squared binomial. So we need to turn it into x plus or minus some constant to the second power. So there's a number of ways that you can think about this. You can think about this as factoring. You can think about this as like trying to find a pattern. Whatever's your pleasure. I know that I need to find a number that adds together to give me this negative 6 and multiplies together to give me a positive 9. It's sort of like the A&M method. So the only number that I can think of that adds to itself to give me negative 6 and multiplies by itself to give me positive 9 is negative 3. If you didn't follow what I just said, you might want to pause the video, rewind it, and re-listen to the explanation because, boy, I am very good at explaining things. Anyway, x minus 3 squared is equal to 25. So what I've done is I've completed my square, my squared binomial. Now what I need to do in order to solve this, because the objective is to solve the quadratic equation as it says here, I'm going to square root both sides. So I'm going to take this whole equation and I'm going to rewrite it, but the opposite operation of squaring, of course, is square rooting. So I'm going to square root that left-hand side, and I'm also going to square root the right-hand side. Now this is very interesting because it actually creates two different equations that I need to work with. when I square root x minus 3 squared, I get x minus 3. That's pretty boring. But when I square root 25, I actually get two different answers. I get 5, and I also get negative 5, because negative 5 times negative 5 gives me positive 25. So I've created for myself two different equations, and I can solve both of those equations individually. I'm going to add 3 to both sides here. And x is equal to 8. And I'm also going to add 3 to both sides on this equation, and I'm going to get x is equal to negative 2. And that's okay to have two different answers because it's a quadratic equation. Quadratic equations usually have two different solutions, or roots, if you want to call them roots. And if you were to graph this original equation, this piece right here, you would see that it hits the x-axis at x equals 8 and x equals negative 2. So that was completing the square. The first step that we used was to get the quadratic equation to say equals 0, just like a normal quadratic equation. Then our second step here was to move the c term out of there. Then we identified our new c term. Then we added that to both sides. We completed the square. In other words, we turned the quadratic into a squared binomial. And then we solved using our normal methods. I'm going to give you another example just to make sure you got it right. So here's x squared plus 8x minus 4 is equal to 0. I know my first step from the previous problem, set it equal to 0, is already done. So the first thing I want to do is I want to move the current c term to the other side. So in this case, my c term is negative 4, so I'm going to turn it into a positive 4 when I move it to the other side. So here I rewrote the quadratic equation, and I showed that I added 4 to both sides. So my new quadratic equation is going to look like this. It no longer has a c term on the left-hand side. On the right-hand side, it has the c term of 4. Now I need to find my new c term, so I'm going to do the same thing that I did previously. I am going to take b, the b term, divide it by 2. I'm going to take the whole quantity, and I'm going to square it. B over 2 squared, you might have heard me say that several thousand times in class this year. I'm going to take this, and my b term, as you can see here, is 8, so I'm going to do 8 divided by 2. That's 4. Square that, that's 16. What's with this small text? That's so bizarre. Stop being small text. Okay, so that is our next step. So the first step was to move the c term, and the second step is to identify the new c term. The third step is to install or add the new c term to both sides. I call it installing that new c term, but that's probably just something a weird math teacher would say. So now I'm going to add 16 to both sides. And now you're going to get x squared plus 8x plus 16, which is a beautiful quadratic equation, plus 16 is equal to 20. Later on, you're going to see that this makes it a little bit messy, the 20 on that left-hand side. But, well, you'll see it in a moment. So now I have a trinomial on this left side, and I want to turn it into a completed square. So the same thing, I want to take it and make it into a binomial that is being squared. And I know that I'm going to put x here because x times x is going to have to give me that x squared. So again, I'm looking for a number that multiplies by itself to get 16 and adds by itself to get 8. So the only number that I could think of that adds by itself to get 8 is positive 4. And lo and behold, it also multiplies by itself to give me 16. So I just created my square. I completed my square. That's why they call it completing the square. Cool, right? I would say so. So our next step, the step that we just took, was we call it completing the square. Complete the squared binomial. Got on the next line. That's a shame. Oh, perfect. Next, if it asks us to just complete the square, we're done. If it asks us to solve the quadratic equation, we can solve using square root. So that's that step that depends on what the question is asking. In this case, I'm not going to show that step. You could square root both sides and then split it into two different equations, just like what we did before. But this is completing the square. This is the hard part. Let's try it one more time. Let's bring our rules that we just wrote on the previous slide and bring them here. And maybe what you should do right now is pause the video, try it, try to just complete the square. Let's not try to solve using square root. And come back to this video when you're done, and I will show you the correct answer. So pause it now. Alright, hopefully you attempted this problem. My first step is to move the c term, and I see my c term is positive 1. So I'm going to subtract 1 from both sides, and I get this step. X squared plus 6x is equal to negative 1. So I can check that off of my list. I moved the c term. Next is to identify the new c. So you remember the formula is going to be negative b over 2a. I'm sorry, negative b over 2 squared. I'm thinking of the vertex formula. Negative b over 2 squared is going to be 6 over 2. That's 6 over 2 squared. 6 over 2 is 3. 3 squared, of course, is 9. So now we've identified the new c term. We can check that off as well. Really good check marks today. Scoring. My next step is to add 9 to both sides. So x squared plus 6x plus 9 is equal to negative 1 plus 9, which is 8. Now I am going to complete the square. I added the new c to both sides, so I should check that off. And complete the squared binomial, I'm looking for the number that adds together to give me 6 and multiplies together to give me 9. And that number is 3. So now what I've done is I've completed the square. I have rewritten this in a different form. Sometimes it'll ask you, the problem will ask you to write it in vertex form. And to write it in vertex form after completing the square is very easy. What I'm going to do is I'm going to take this quadratic and I'm going to change it very, very slightly. It's still a quadratic equation. And you remember from quadratic equations that we learned about all throughout this year, a quadratic equation is at its finest when it says equals 0, but this says equals 8. So I want to make this say equals 0 in order to put it in vertex form. I, of course, need to subtract 8. So if I subtract 8 from both sides, I'm not going to be able to subtract 8 from x minus 3 in parentheses squared, because you can't subtract through a parentheses like that. But you can write it like this. We'll take x plus 3 squared, and we'll just say minus 8. That's an 8 is equal to 0. This right here is in so-called vertex form. It's called vertex form because it tells us something about the vertex of the quadratic equation, and I can tell you right now what that means. It means that the vertex of this quadratic equation, without even graphing it, the vertex is going to be negative 3, comma, negative 8. And if you're wondering why this is the vertex of the quadratic equation, you're going to be seeing that a lot more in future math classes in Algebra 2 and in Geometry, respectively. Anyway, so we've completed the square with that one. Last but not least, what happens if there is a number in front of the squared term? Well, you can't complete the square if there's a number in front of the squared term, but sometimes there's ways around it. See if you can think of, I'll pause the video now, see if you can think of one way to get rid of this 2 in front of the squared term. Okay, hopefully you were able to try it. The first thing that you should have done is observe that all of these are divisible by 2. So 2p plus 20 is equal to 6p. Let's divide every single term by 2, and we get p squared plus 10 equals 3p. I subtract 3p from both sides to get it to equal to 0. Then I'm going to follow my steps. My first step was to remove the c term, and then I'm going to do my b divided by 2 squared step. So in this case, my b term is negative 3, so my b divided by 2 looks like this. A little bit different from the previous problems because it gives you a decimal, but that's okay. I'm going to take that exact decimal, add it to both sides, and now I have my trinomial. Now the only thing left for me to do is turn it into a perfect square by taking this term and cutting it in half. That term cut in half becomes the last number. Hopefully this video on completing the square was useful. Good luck studying, students.